Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome to APSEC's online support program, Class 9, Week 10, Chapter number 2, Subject Chemistry, prepared by Maryam Qureshi. Textbook Chemistry, page number 30 to 41. Chapter number 2, Structure of an Atom. Topics included in this chapter are Rutherford's atomic model, Bohr's atomic theory, and electronic configuration. Objectives. By the end of the lesson, students will be able to know about Rutherford's atomic model, Bohr's atomic model, and electronic configuration. But as I already discussed Rutherford's atomic model in my first video, in this video I will discuss only Bohr's atomic model and electronic configuration. Bohr's atomic model. Bohr atomic model was proposed by scientist Niels Bohr in 1913. As in a Rutherford atomic model, we discussed that the scientist Rutherford was failed to explain the position of electron, the energy of electron, and the spectrum of electron. Different scientists work on these defects, but finally scientist Bohr successfully explained the energy of electron in an atom, the position of electron in an atom, and the reason behind the line spectrum of for the energy of electron in an atom. Following given below are the some postulates of the Bohr atomic model. First postulate of the Bohr's atomic model is that electrons revolve around the nucleus in a circular path called shell orbit or energy level. Each orbit has fixed energy. Scientist Bohr said that the electrons are moving around the nucleus in a circular paths called shell orbits or energy levels. Actually, shells orbit or energy levels are the place where the electrons are actually present. Each orbit has a fixed energy. This means that the energy of electron in a given shell is specific. Means if it resides in the first shell, it will have a specific energy. Then if the electron is present in the second shell, then its energy will be different than the energy of the electron in the first shell, and so on. The second postulate is the energy of electron is directly proportional to its distance from the nucleus. The farther the electron from the nucleus, more energy it has. This means that the energy of electron in a given shell depends upon its distance from the nucleus. The farther the electron from the nucleus, greater will be its energy. If you look at the given below picture, n is equals to 1 means first shell, n is equals to 2 means second shell, and n is equals to 3 means third shell, and so on. So the energy of the electron in the first shell will be less than the energy of the electron in the second shell, and the energy of the electron in the second shell will be less than the energy of the electron in the third shell, and so on. Third postulate is the angular momentum of an electron is an integral multiple of nh divided by 2 pi. It's very important postulate. N shows the number of shells in which the electron is present. H is the Planck's constant and is given by scientist Planck, and its value is 6.6262 multiplied 10 raised to the power minus 34. 2 pi, you can consider it the circumference of a shell or orbit or energy level in which the electrons are present. This statement simply means that the angular momentum of electron directly depends upon the shell in which it is present. Fourth postulate is energy is absorbed when electrons jump to higher energy orbit and emitted when electrons fall into the lower energy orbit. This means that when electrons jump from lower energy orbit to higher energy orbit, means from first shell to second shell or second shell to third shell, then it will absorb energy in the form of photon. And when electrons jump from higher energy orbit to lower energy orbit, means from third to second shell or from second to first shell, then it will emit energy in the form of photon. Fifth point is electron neither emit or nor absorb energy when it remains in a particular orbit. Mean that if electron reside in one orbit, then never ever it will lose or gain energy. Sixth postulate is the energy of light emitted is exactly equal to the difference between the energies of the orbits. Delta E is equals to E2 minus E1. Delta E is the energy difference between the energies of any two orbits. E2 shows the energy of higher orbit or the energy of second orbit, and E1 is the energy of first orbit, or you can generally say that the energy of lower orbit. If you want to find out the difference between the energy of two orbits, then simply subtract the value of high energy of electrons in the higher orbit from the energy of electron in the lower orbit. Then simply you will get the difference between the energy of any two orbits. Okay, it was all about Bohr's atomic model. Now come towards the last topic, which is electronic configuration. Now what is electronic configuration? Definition: the distribution of electrons, or you can say the arrangement of electrons in the shells and subshell of an atom, is called electronic configuration. Like for example, in class, teacher arranged the students in different rows. Each and everybody have its own seat, and all the students sit on their own seats. Same like that, the scientists arranged the electrons in the shells and subshells of an atom, and that is called the electronic configuration of an atom. Now what are shells? I already discussed in Bohr atomic model that the circular path in which the electrons are revolving around the nucleus are called shells, or orbits, or energy levels. Symbol: the number of shell can be represented by symbol n. N can have a value from 1 to 3 and so on. As there are 7 periods in the periodic table, so the value of n will be from 1 to 7. Look at the given below picture. In below picture, a positively charged nucleus is shown, and around the nucleus 4 shells are shown. 1 means n is equals to 1, means first shell, and its name will be K. 2 means n is equals to 2, means its second shell, and its name will be L. 3 means n is equals to 3, means third shell, and its name will be M. And 4 mean n is equals to 4, and its name will be N. As electronic configuration is the arrangement or distribution of electron in the shells and subshells of an atom, so the question comes in our mind that how we can find out the number of electrons in a given shell, means how much electron we can put in a given shell. So you will use a formula, 2n2 formula, to find out the number of electrons in a given shell. In 2n2 formula, n shows the number of shells in which you want to find out the number of electrons. So if you want to find out the number of electrons in the first shell, put the value of n equals to 1. If you want to find out in the second shell, then put the value of n equal to 2. If you want to find out the number of electrons to be filled in the third shell, then put the value of n equals to 3. Now come towards the subshells. Subshells definition: a shell or energy level is subdivided into subshells or sub-energy levels. Like for example, in homes we make rooms, in school we make different block for different classes. Same like that, the scientist and chemist make some subdivisions in the shells of an atom, and that subdivisions of shells and are called sub-energy levels. Now there are 4 subshells: S, P, D and F. S, the word S is derived from the word spherical, P is from principal, D is from diffuse, and F is from fundamental. Now how much electrons a subshell can accommodate? So S subshell can accommodate maximum 2 electrons, P subshell can accommodate maximum 6 electrons, D subshell can accommodate maximum 10 electrons, and F subshell can accommodate maximum 14 electrons. Now students, it was all about Bohr's atomic model and electronic configuration. Recap. Students, in this tutorial we have learned about Rutherford's atomic model, Bohr's atomic model, and electronic configuration. Tasks assigned. Students, first of all, write electronic configuration of first 18 elements in a simple way, by using a simple way, not according to Aufbauer principle. Solve self-assessment 2.1, self-assessment 2.2, and self-assessment 2.3. Now chapter 2 has been completed, and in the next video I will start chapter number 3. Thank you students.